Right now you might be asking, wait a minute, what's this guy saying? But actually what I'm saying is something rather elementary. If you run an experiment many times and record all of your measurements as well as is humanly possible, the likelihood that the mean of your measurement moves closer and closer to the true mean value increases. However, at the same time, the likelihood of observing a mean that is exactly equal to the true mean becomes smaller and smaller. Zero, essentially. Actually, you can think this through in terms of a simple coin toss experiment in which you throw a coin into the air 4 times. Each time you throw the coin, it must come down either heads or tails. So, if you draw out all the ways the coin may land, heads, 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 tails, heads, 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 tails, tails, heads, etc., you will find that all the ways the coin may, you will find that there are 2 to the 4th equals 16 possible coin sequences that could occur from this experiment. Each of these outcomes is equally probable since the event is considered entirely random. Yet if you look closer at these possible outcomes, you may notice that only 6 of them actually provide the expected equal number of heads and tails. This means that in only 6 of the 16 cases, you'll find the exact 50% ratio, which you would expect on average. And in that 6 of 16 cases, that's about 37.5%. This is with 4 tosses, and if you make it 6, you're already down to 31.25. Throw the coin often enough to have any chance of ever being published into a scientific journal, let's say 1,000 times, you're likely to be down to the probability of virtually 0 of exactly hitting the 50% mark. This alone is of course not a problem, but it is the reason for why we have to perform statistical significance testings in the first place, since accepting that we're very unlikely to ever record the true mean for our experiment implies that we need to find a way to derive an assessment of what the true value might be from what we see in our measurements. Not an easy task. A way that a scientific researcher will typically go about his problems is to tackle it from the opposite angle, but by essentially asking which values may we exclude as possible true values given our measurements. And the best way I can currently see of approaching this question for BEM's research within the limits of a blog post may be to walk you through an example that is extremely close to the BEM research design but uses the already introduced coin toss experiment, and here's how it goes. Suppose I claim to you that I have an extraordinary ability that allows me to influence coin tosses. You are part of a group of scientists and you flip a coin 6 times, and on your first attempt you actually come up with 6 heads. This amazes you. You have never been a very lucky person, and you ask yourself the 2 fundamental questions that a scientist must ask in this case. 1. Given my original hypothesis that the coin toss is random, what is the probability that this guy influenced me into throwing 6 heads? 2. Given this probability of 6 heads, how strong a reason do I have to believe that he actually has superpowers? Luckily, your first question is one that can easily be answered by the cheapest calculator offered at Walmart. The probability of observing 6 heads in 6 coin tosses, given a truly random coin, is exactly 1/64. That's less than 2%. Not so luckily, the second question asks for a thinking mind, as it really requires you to think about everything you know of how the universe works, how coins flip and fall, and what randomness truly means. In the case of the coin toss, I assume that everything you know about the universe makes you skeptical enough to demand that I at least attempt this feat again. Maybe again and again, over and over. Possibly hundreds of times. So you may see how my coin tosses come out on average. And as you would do with the coin tosses, so does Ben in his research when he asks hundreds of people in his laboratory and lets them guess between icons hundreds of times, and lets the computer randomly assign a priming picture after each of the hundreds of guesses have been made, and meticulously records how often each of these hundreds of guesses turned out to be correct. From doing this with several types of different pictures: erotic pictures, negative pictures, neutral pictures, and positive, non-erotic pictures. And, looking at each of the results, the evidence he asks you to be convinced by is plainly this. His subjects were able to guess the erotic pictures exactly 53.1% of the time. It is up to you to ask yourself whether you find this to constitute convincing evidence for a psi phenomenon. Before you make your call on the above, I hope you'll let me take you back to the coin toss experiment for another moment, though. In the earlier coin toss experiment, did you notice that I did not tell you in advance whether my ability meant that I could make you throw 6 heads, or whether it meant that I could make you throw all tails? Don't you think it would have made a difference how you would have interpreted your findings? Also, do you see a qualitative difference between predicting that I personally will throw 6 heads, or whether you predict 6 heads for at least one of the 4 researchers in my team? Both of these questions arise with BEM's research. The first one has to do with the use of the one-sided t-test, which is maybe being too nitpicky here, since the one-sided test is in line with BEM's overall narrative, but the latter question deserves attention. If you look at the entire paper, there is no less reason to believe that the people should be able to muster premonition in order to detect erotic pictures. Then there is reason to assume that subjects should be able to avoid negative images. Indeed, this is why BEM investigates both possibilities alongside the others mentioned above. His findings eventually indicate that only erotic pictures display an effect that passes conventional statistical significant thresholds, meaning that mathematically you would expect to see an overlap of 53% or higher between the participants' choices and the computer's assignments with less than 5% probability, assuming that computer assignment was truly random and independent. Such is the conventional thinking of using p-values to ascertain statistical significance. But it must be clear that although the possibility of the single effect is less than 5% of the possibility that at least one of the 4 effects would pass this threshold is, of course, much higher. You may think of this in terms of Las Vegas. Example: if you are at the roulette table and you want to bet on a particular number, the chance that you will get it correct is measly 1 over 37. There are 36 number fields plus a 0 in roulette. But now, think of what happens if you spread your bets across 4 different numbers. Now the probability that you will get at least one of the 4 right is actually 4 times the 1 over 37. Indeed, if you put money on all the numbers on the table, you are almost guaranteed to win on some number, unless you have the bad luck of the 0 roulette roll. So, leaving Las Vegas behind, but seeing that BEM figuratively places bets on multiple hypotheses, does very little to convince me that this was more than mere luck. Sadly, by now, this has become a much longer blog post than you cared to read. Yet, there is one more issue I hope you will bear. The It addresses the second fundamental scientific question you must ask yourself in order to interpret Bem's research, given the results as they are, and the probability that they may have occurred with the chance of less than 5%, less than 2% even, given that the events were truly uncorrelated and random. What is the strength of the argument that we are seeing is actually due to psychic activity? Although even the statistical rationale for answering this question relies essentially on what your beliefs are to begin with, there is an illustrative way to think about how the underlying statistical reasoning works. Suppose you conduct a pregnancy test and it shows up positive. You know that those tests show a positive 90 out of 100 times for people who are actually positive, and 4 out of 100 times for people who aren't pregnant. And that these are just false alarms. So you are now in the predicament that your test is positive and you want to figure out whether to believe that you are actually pregnant. A very simple, everyday life question indeed, but not the easiest thing to calculate, unless you know Bayes' theorem. But let me make it easier by adding one more tiny detail. You are 80 years old, virgin, and a man. It should be clear that under these circumstances, it should not, how small the probability of a false alarm is, although it is statistically significant, less than 4%, because your overall understanding of the world dictates that the prior probability of pregnancy for you is 0. This is obviously an extreme example, but it is to illustrate that the prior probabilities matter a lot when you want to interpret what your disconfirmed null hypothesis and positive pregnancy test really means. If you are a 23-year-old woman and have unprotected sex several times over the last weeks, you will interpret your result differently. And if you're approaching menopause and had sex only once last month, which, by the way, is not supposed to be a reflection of how often I believe women of different ages have sex. It's possibly the other way around. In Ben's case, he clearly views psi phenomenon as a 23-year-old want-to-be mommy, while I view it as the 80-year-old virgin man. Professor Ben is as entitled to his view as I am to mine, and you are entitled to yours. But if I took one look, but if you look one more time at our coin toss example, you may ask yourself this precise question. If you record 53% heads on a total of 1,000 attempts, even if you manage similarly unlikely things on 9 different occasions, how convinced should you be that all of this is due to my paranormal powers and not just a result of chance, measurement, error, experimenter influence with magnetic coin, or other explanation that you might come up with? You can decide this on your own, but realize that whatever your answer is, this must also be your answer to how confident about Professor Ben having truly proven the existence of psi phenomena. 40-year-old, menopaused, sex last month,